Hey everyone, as I promised you, I'd do a little mini lesson video on the conservation of mass, and I would do a few of these problems for you so that you would see how they're done. Before I go any further, remember I'm not taking this for a grade, but this is an important resource that you can use for learning target number 4, which is focused on understanding the conservation of matter or mass. And this idea of conservation of mass states that matter cannot be created nor destroyed. So what we should see on this worksheet is that there should be an equivalent amount of reactants to the products. The way that we're going to do that is we are going to count the number of atoms on each side of the chemical equation. We did this first one in class. On both sides of the chemical equation, we only see oxygen. On the reactant side, we have a subscript, O2. I have to multiply that by the coefficient 3. So I have 3 oxygen molecules. In total, 3 times 2 gives me 6 total oxygen atoms. So according to the conservation of mass, I should see the same thing on the product side. In this case, 2 times the subscript 3 is 6 oxygen atoms. So in fact, this equation is balanced, and it shows the conservation of mass or matter. Let's skip ahead to 13. The reason I'm skipping to 13 is because a common misconception that I'm seeing is that kids will see 2 letters in an atomic symbol and think that's 2 separate elements. In fact, Mn for manganese, a type of metal, is a single element. Cu for copper is a type of element, and Cl is a nonmetal, chlorine. So that's what we're going to account for on each side. We're going to see how much manganese atoms there are, copper, and chlorine. So remember, atomic symbols can either be 1 or 2 letters. If they are 2 letters, the first symbol of that, the first letter of that atomic symbol will be capitalized. The second one will be lowercased. Anyways, I have 1 single manganese atom because, as you see, it does not have a subscript. If it is just the atomic symbol, we can assume that it is a single atom of that metal. Copper, however, even though it doesn't have a subscript, has a coefficient in front of it. I will have to multiply each individual atom here by 2, giving me 2 copper atoms and 2 chlorine atoms. In order to see the conservation of mass or matter, I should see the same thing on both sides. So let's test that here. Right away, manganese does not have a subscript attached to it. The chlorine does, but the manganese does not. So far, I'm good for manganese. Copper. 3 times the single copper atom gives me 3. So immediately, I see that copper is not balanced. So this is not showing me the conservation of matter. And I can do the same thing here. Chlorine is balanced, but you would have to do more work in order to balance this equation in order to show the conservation of mass. So you would say this one does not. Now remember, we're not just doing yes or no answers to this. You were supposed to write your own brief justifications to whether or not the following equations prove the law of conservation of mass on a separate sheet of paper. I will post the sentence starters and guide for that as well on Schoology. I hope this helps. I will make sure I post an answer key for all of these shortly, but follow this same process when you're trying to prove the law of conservation of mass. Count the reactants and products, see if they're equal on both sides. If they are, it shows the conservation of mass or matter. If they aren't equal on the reactants and the product side, it does not show this. Thanks and have a great night.